Hey everyone. All right, so next up, hypothesis testing for proportions. So back to z-scores again, which tells you that we're going to be dealing with sample sizes bigger than 30. And for proportions, to be honest, or for proportions, to be honest, these sample sizes tend to be pretty big. So you'll see in the problems, they're generally in the hundreds or thousands of sample sizes. So doing a hypothesis test for proportion takes a little bit more people typically. Now, the equation that we're going to be using, other than pretty much the fact that we're going back to z-scores, is going to be a new equation. I'll show you in the examples how this works, but a couple rundown of some of these variables, which you've seen before in some of the previous problems that we did with confidence intervals. So, P with a hat, this is going to be the sample percentage. So I would jot that down. Sample, can't spell. P is going to represent the claim percentage. So this is the one that you write in your null and alternative. That's the P. Q, you'll see it again down here, the P. Next to that, the Q, you've seen this before. This is what is known as the opposite percentage. So for instance, if your P is 20%, your Q would be 80%. If your P is 40%, your Q would be 60%, so on and so forth. They both have to add up to 100%. One way to quickly do this is to think of this in decimal terms, is to find Q, you can subtract P from 1 to get that opposite percentage if you need it. And then last but not least, N, as always, represents the sample size. I think we are now good to go. So let's take a look at one of these problems that I wrote out in my beautiful penmanship. Here we go. So a Roper poll claims that 5% of the U.S. Or U.S. adults have had dreams about UFOs. Weird. You decide to test the claim and ask a random sample of 250 U.S. adults if they have had dreams about UFOs. Of those surveyed, 8% said yes. At a level of significance of 0.01, is there enough evidence to reject the claim? All right, so as always, we're going to start with the null and the alternative. The claim is that 5% of U.S. adults have had dreams of UFOs. So I know in the past we've been using mu because we've been dealing with averages. In these problems, we are going to start using P instead of mu, obviously, because we're dealing with percentages. So our claim, honestly, is P is going to equal, or the percentage is equal to 5%. Now, you can write this as a decimal. Now, in the claim, I generally just write these as percents. It's really up to you how you want to do that. The opposite of this would be not equal to, but first let's figure out which null or alternative hypothesis to put this claim in. Because there's an equal sign, we're going to write that as the null hypothesis. That's going to be our claim. The opposite of that, again, is not equal to, and that is going to be our alternative for this problem. We are going to be doing a two-tailed test because when the alternative is not equal to, we do a two-tailed test. So I'm going to draw that test in. And we're going to write z-scores below these. So we'll get out our t-table. I'm going to have you do that and find the z-score that's associated with 0.01. And again, we are dealing with a two-tailed test. So I'll give you a second to look that up. Looking that up, you should have seen, or you should see, the z-score of 2.576. And because we are doing a two-tail, we're going to write a negative 2.576. That's in case our sample percentages drives us to the left side of this, or if it's below the claim percentage. And then we'll also have a positive 2.576, and that's if our claim percentage happens to be above, it'll deal with both situations. All right, so there's our z-score. Now we're going to get into the math part. So let's just write, for this one, we're going to just kind of label everything out. We're going to write them now as decimals because in the math problem, you always want to deal with decimals, not percents. So p hat in this problem, again, is going to be 8%. So I'm going to write that as a decimal because that's how I'm going to plug it into the problem. The claim percentage is going to be 5%, so 0.05. The Q in this problem, or the opposite percent, is going to be 1 minus that 0.05. But if you think about it, the opposite of 5% is, again, 95%. So it's no surprise that 0.95 is going to be my Q. And then last but not least, the sample size for this problem is going to be 250. Now I'm going to get my test statistic, which is, again, that equation from above. So I'm going to just plug everything in here. Z equals 0.08 minus 0.05. It's going to be on the top there. And then it's going to be divided by the square root of p, which is 0.05, times q, which is 0.95, divided by the sample size, which is 250. So now I'm going to jump onto my calculator, and I'm going to go ahead and calculate. And as I'm stumbling to do that, I invite you to go ahead and do the same and see if we get the same result. So 0.8 minus 0.05, I tend to find that answer first, and then I divide, and I just go ahead and make sure that the order of operations is good. So I do the square root of 0.05 times 0.95. If you did this correctly, I am getting 2.18 if you round. So 2.18 is going to be our test statistic. And as always, we're going to compare our test statistic to our number line over here. So 2.18 technically actually puts us to the left of this, but obviously right of that. Again, think of, 0 in the middle. So 2.18 would actually put us in the middle region here, so not in the shaded area. Because we're in this region, that's going to make HO true, HA false. So because HO is our claim in this case is going to be true. And that would be the answer. If you want to be more specific, can you reject the claim is what it's asking us, and the answer is no, we cannot reject the claim. The claim is true. So that is one example. Let me try one more. So in this particular example, a Pew Research report claims that more than 30% of U.S. adults regularly watch the Weather Channel. You decide to test this claim and ask a random sample of 75 adults if they watch the Weather Channel. Of those 75 adults, 27 respond yes at a level of significance 0.01. Is there enough evidence to support the claim? All right, so let's start by writing the claim in symbol form. So here we go. The claim is that the percentage is more than 30%. Because of that symbol, that's going to put us in the alternative hypothesis because, again, no equal signs or what stuff without equal signs go in the alternative. That's going to be our claim. Now I'm going to write the null. The null is opposite of that, so the opposite of greater than would be less than. But again, because it's the null, we'd throw an equal sign in there. And that's going to be 30% as well. All right, so we got our null and alternative. Let's go right and do our tail test. The alternative of greater than means that we are going to be doing a right tail test. And I'm going to let you go on to the t-table and see if you can find the z-score for a one-tail test of 0.01. Give you a second to try that out. The one that I'm getting is 2.326, and it's positive because it's on the right-hand side of this tail test. And those are the first two steps. Let's go into the next part. So for our equation part, we're going to start with the sample percentage. Now, the sample percentage, it's not clearly given to us. And when that's the case, you actually have to do a little bit more work. Now, they don't tell us the sample percentage, but they do give us how many people said yes. So the way we get our sample percentage, if it's not given to us, is do a quick little fraction. So we'll do the number of people that said yes over the number of people sampled. So 27 divided by 75 gives us 0.36 or 36%. There's our sample percentage. Our claim percentage is, again, 0.30 if we write that as a decimal. Our Q, or 1 minus this, is going to be 70%, or 0.70. And then last but not least, our sample size is going to be 75. So let's do our test statistic real quick. So z equals 0.36 minus 0.30 over the square root of 0.30 times 0.70 divided by 75. So again, I'll give you a second quick head start to see if you can go ahead and calculate that. I'll do the same. Here we go. 0.3 times 0.7 divided by 75. And I am getting, and hopefully you got the same thing, 1.13. So that's my test statistic. All right, so 1.13. That puts us in this section. So 1.13 definitely is to the left of 2.326. So that puts us over here. So because of that, HO is true, or HO, I should say. The null is true. Again, HA, or the alternative, is false. However, our claim is the alternative. That would actually mean that our claim is false. So the claim would be false this time. So to answer the question specifically, is there enough evidence to support the claim? And the answer is no, there's not enough evidence to support this claim. It's probably more of the lines that it's equal to 30%, not more than 30%. So those are two quick examples of how to do proportions tests. Today's assignment is going to have you do 6 more of these problems. Hopefully that makes sense to you. If you have any additional questions, again, Monday through Thursday, we have office hours between 1 and 2 p.m. I will see you there, or if not, have a wonderful day. See ya.